Good morning, dear students. Already we have started with that introduction to embedded system in that previous video. Now we are going to start that next topic, that is design process of an embedded system. When you are designing a complete embedded system, what are the steps we have to follow to design that system, that we are going to discuss. The first step in this one is abstraction. Abstraction is to identify the requirements and give the specification and identify the architecture, the components needed for designing that one, then finally the entire system integration. The next step is hardware and software architecture. We have to design the hardware and software needed for the entire embedded system. Then extra functional properties, additional functional properties needed for designing is added into this one. Next we have to system related family of design. We have to identify what all the related systems are available in that same properties or in that same solution. Next we have to design a modular format for that exact system, and then we have to map into that original system. Then we have to design whether it is user interface or not. We have to design a user interface system. Then we have to refine it based on the feedback of the user. We have to refine it also. Let me start with that brief introduction of that design process of an embedded system. First one is abstraction. Abstraction is that each problem component is first abstracted. First, that is, you have to get the idea. You can get the idea from some of your customer care or the voice of the customer. We have to identify the problem, and from that problem we have to identify that each problem component is first identified, extracted. In design of a robotic system, the problem of abstraction can be in terms of control of arms and motors. So this is an example. When you are designing a robotic system, first we have to identify how we are going to control the arms and the motors that controls the arms. Next, hardware and software architecture. Architecture should be well understood before the design. So before starting any design, we have to bring that block diagram. From the block diagram, you have to identify what all the hardware architecture needed for designing that system. Similarly, in order to control the hardware, what all the software needed for that one, that we have to identify, we have to understood for before starting our designing. Next, extra functional properties. That is, extra functionalities required in a system being developed should be well understood from the design. So what are the additional facilities we have provided, that should also understandable. Then system related family design. Families of related system developed earlier should be taken into consideration during the designing. When we are designing any module, that is, when we are designing, suppose we are designing a robot, we have to consider previously designed robots, what all the design methodologies they are taking, what all the problems they are facing, that things we have to consider. Then modular design. Modular design concept should be used because system designing is fast by decomposition of software into modules that are to be implemented. When you are designing that, when you are decompose the entire program into smaller modules, then it will be very easy to write the program codes, or a set of people can work in different modules. It reduces the timing for writing the codes. But when you are designing that modules, we have to concentrate on that module should be clearly understood and should maintain continuity. Also, appropriate protection strategies are necessary for each module. A module is not permitted to change or modify another module functionality. For example, protection from a device driver modifying the configuration of another device. We should not allow that one. Okay. So when you are going for the modular design, each module should be defined, it should be composed, and they have to be reintegrated with the other things. Okay. Next, mapping. Mapping into various representation is done from software requirements. For example, the data flow in the same path during the program flow can be mapped together as a single entity. Transform and transaction mapping design process are used in design. For example, if you are taking an image processing, if the input of the image is the data is the color and size of the pixels and other that is it can be different number of pixels and colors. The system does not process each pixel and color individually. It has to take that entire pixel value as an image. Okay, transform of image is done by appropriate compression and storage algorithms. Transaction mapping is done to define sequence of images. So when you are mapping that one, there should be one entity and it has to be mapped to the appropriate format. Next, user interface design. User interface design, we are designing everything for the customers, so it should be customer usable, understandable, customer usable. So user interface design is an important part of the design. User interfaces are designed as per user requirements, analysis of environment and system functions. For example, in an automatic chocolate vending machine, the user interface is the LCD, real-time graphics display. It can display the welcome message as well as specify the coins needed to be inserted into the machine for each type of chocolate. The same automatic chocolate vending machine may be designed with a touchscreen user interface, or it may be designed with voice user interface, but any of these interface design has to be validated by the customer. For example, the automatic chocolate vending machine customer who installs this machine must validate message language and messages to be displayed before the interface design can proceed to be implementation stages. Next, refinements. Each component and module design needs to be refined regularly till it becomes most appropriate for implementation by the software team. The software design process may require use of architecture description language. It is used for representing the follows, that is control hierarchy, structural partitioning, data structure and hierarchy, then software procedures. Next, we are going to discuss about the characteristics of embedded system. When you discuss about the characteristics of embedded system, it should be operated in the real time, and its size and the weight, that should be very important. How much power it is consuming, how harsh it is working in that environment, and the safety and critical operations, and then finally the cost and the sensitivity. Let me go for that brief introduction, brief about the characteristics of the embedded system. First one, application and domain specific. Embedded system do a very specific task. They cannot be used for any other purpose. Both hardware and software in an embedded system are optimized for the specific task. For example, we cannot replace the embedded control unit of a microwave oven into air conditioner control. Then next one is reliability. Embedded system have to work for thousands of hours without break, because we are using always the embedded system in an automatic control unit. Okay, so they have to continuously working. This calls for very reliable hardware and software. For example, if the embedded system comes to halt state due to some hardware error, the system should reset itself without any human intervention. Reliability is a measure of how much percentage we can rely upon the proper functioning of the system without failure. Next, reactive. Embedded systems are in constant interaction with the real world through sensors and user-defined input devices. Any changes happening in the real world are captured by the sensors or input devices, and control algorithm reacts in the changed manner to bring the control output variables to the desired level. For example, if you are taking the temperature sensor, that is a room temperature controller, if the temperature in the room is above the threshold level, it has to increase the cooling system. Okay, if it is below the temperature, it has to switch off that cooling system. So hence the embedded systems are referred as reactive system, as they produce changes in output in response to the changes in the input. Next characteristics, this real-time performance. Real-time system operation means the timing behavior of the system should be deterministic, meaning that the system should respond to requests in a known amount of time. That is, when you are going for an automatic teller machine, that is ATM, if you are giving an input, then you will wait for few minutes only. So it should not take more time to give that vending that money. So in real-time embedded system, a specific job has to be completed within a specific time. They have time constraints and they have to work against some deadlines. For example, real-time system in missiles, flight control system, nuclear plane and safety system, we cannot wait for more time. Okay? A real-time system should not miss any deadlines for task or operation. For example, in a nuclear plant safety system, missing a deadline may cause loss of life, damage to property. Hence, in hard real-time embedded system which are subject to very strict deadlines for performing specific tasks, the timing analysis is of great importance in that real-time performance. Next, low power consumption. Most of the embedded systems operate through a battery. So to reduce the battery drain and to avoid frequent recharging of the battery, the power consumption has to be very low. Hardware designers must address this issue. For example, by reducing the number of components, by designing the processor to revert to low power mode when there is no operation to perform. Then operates in harsh environment. Some of the embedded system are to be operated in harsh environment conditions like high temperature zone, areas subjected to vibration and shock, etc. So system placed in such areas should be capable to withstand all these adverse operating conditions. Next, we have to go for the components of embedded system. So we will discuss that in the next video. So far we have discussed about that designing process of an embedded system and the characteristics of embedded system. Thank you.